All right, so this is the second part of our video. Shh, let's get quiet, please. And on page 412, number 1, it says airplanes. Find the rate of change between points E to point F in the airplane position graph above. So I want you to go ahead and look up there. Look at the graph there on that page. And you're looking between E and F. Find its rate of change. So remember, rate of change is the change in Y over the change in X.
We have to write that every time.
No, but do it for your notes for this part. Just because I want that to really become ingrained in your mind that the Y goes on top, the change in Y over the change in X. And Mason, you had your hand up. What did you find to be the change?
So it's 2 up and 1 to the right.
Okay, yes, but does every square represent only one amount?
No,
Like 1 unit? Okay, you're right. Each jump is really 400. So how much does it really go up from E to F? 800. And then 400 to the, is it 400 on the bottom?
No, it's
800 up.
And how much is it counting on going to the right, on the feet?
It counts 200. They just don't put 200 in the middle. It's 200.
Every box across the x-axis is 200. Do you see that? The way they have the numbers underneath? It's not that clear, but hopefully you can see it.
Do we need to write?
Okay, Sebastian? So now, a rate of change is a fraction, a rate, so it should be reduced. So we'll cross out our zeros, divide by 100 there. And then we can divide the 8 and the 2, reduce that to 4 over 1. Okay? All right, look at the page there on the right, 413, and let's look at number 2. About exercise. All right, Avery, why don't you read that one for us? And it's Alondra.
Alondra used a pedometer to keep track of the number of steps she takes on a walk. Find the rate of change.
Okay, go ahead. Let's try it. There's no graph, but they give you the numbers. It's almost easier, really. Okay? So go ahead. Find the rate of change.
Oh, I see. That's... We just put Y over X.
Well, I'll show you. There's a little notation you're going to see me use later, but I can go ahead and use it now. And I learned it, I believe, in science class. And it's a triangle means the change in. That's a little notation that they use. So let's actually start using that because it is a lot quicker. So when you see a little triangle in front of that Y, that means the change in. Yes. So the change in Y means you've subtracted 2 amounts. The change in X, you've subtracted 2 amounts. So it's not just a Y and an X. That's why it's good to have that. I don't know where the triangle for that, why that's that, but that's just the way it is.
Do we have to write triangle?
You might as well.
For homework.
Sure. Yeah, you can do that. Okay, so what do we subtract for the Y's? Okay, what did you get, Max? 192. Now, I noticed that he did 480 minus 480 minus 288. So, and you said that was 192. So, should I go 3 minus 5 on the bottom?
No.
What's wrong with that?
5 minus 3.
Why? Do you see how you're not being consistent?
What about 3 plus negative 5?
Because you switched the ball.
So that's, yeah.
So you have to switch it again.
Right. You just have to be consistent. If you start with the bottom number minus the top number, then you need to do the bottom minus the top because 3 minus 5 gives us a negative, doesn't it? But, so let me go back and switch that up. And we get 5 minus 3 is 2. And then what can that simplify to be?
That number.
87,
I think I heard it.
87.
No?
87. 81. No, it's not.
93.
Divide. You guys obviously need to divide it.
Oh,
Please have
192.
Okay, Mason, I hear it had it 96. Now let's label these because this is tied to a word problem. 96 what?
One. Oh.
What are those? What are the Y's?
Steps.
Steps
What? Oh, I'll look at it.
over 1
Minute.
minute. Do you guys see where those labelings come from? So it's labeling a rate.
That guy's slow.
Now, what if, I want to show you how this is the same. We could have done 288 minus 480 over 3 minus 5. Well, that's taking the top minus the bottom. The top minus the bottom. And then what would the top number be if you subtracted there? Negative 192 over negative 2. Do you still get the same thing?
Yeah.
So as long as you're consistent, the order really doesn't matter. All right, let's look at another one. Number 3 at the bottom.
That's the L. That
Yes.
arrow you drew looks like a perfect nose.
A perfect nose?
Yeah.
It does.
Oh, right here?
Oh my
Yeah.
gosh.
Yes, it
It
does.
does.
Screenshot this, Neil.
You should be seeing this.
Okay. All right. Number 3 about money. The very bottom of the page. It says, quiet in the back, please. The table shows the amount Y remaining in Lauren's savings account after X weeks. Find the rate of change. Interpret its meaning. Okay, so you go ahead. Find the rate of change. And then we'll talk about how to write an interpretation.
Please simplify it.
Yeah, bottom of the same page. Correct. Yes. See there at the bottom about money?
Oh, that was 3.
Oh, it was kind of a funny 3. Okay, Sebastian, help us out because you're chatty back there. How do I find the change in Y? What did you do?
160.
Okay, so what was your change in Y?
Oh,
What?
40.
Okay. All right, what about the change in X? Now, who can do that one? Let's hear from, okay, Avery.
You have to keep it like the same. So you do 4 minus 6 and it's negative 2.
Okay, very good. She said you have to keep it in the same order. So because Sebastian started with 160, she had to start with 4. So 4 minus 6, we get a negative 2. So it's, okay, what do you, well, I'll ask that in a second. So then let's reduce it. What would that be? 20 over negative 1, or you could just say negative 20. You can put the negative really on either part. We can keep the negative on the bottom if you like. Okay, he's just interpreted. Well, but what is it? It says that she, instead of saving, what do you think she's doing? She's probably spending. Okay, so because this is money, and then per week, so we could say that she spends, this would be your interpretation, $20 per week. Because it went down, right? She spent it rather than saved it.
So if it was positive, you say she earns.
Yeah, or saved. Okay.
Wait, but if it's 2 weeks, how did she spend $2?
2 is with 40.
I get it. 40.
Okay. All right, let's draw this quick graph here. Go ahead, draw this X and Y axis, this coordinate plane. You can just do it in your spiral. This all, and we're just doing a little bitty bit here.
Bitty bit.
A little bitty bit. I'd like you to find the rate of change on that graph, and then I'm going to draw one more, and then we're going to compare. And I'll even put the ordered pair. So what's this ordered pair? -1, 0. And this ordered pair is 1, 3. So if that helps, you can use those two.
We have time to do it.
Okay, go ahead and find the rate of change on this one.
You have to draw it.
Oh yeah, it'd be good to draw.
Are these like trick questions or are these actually?
These could be actual questions. Okay? You should draw them, and then I want you to find the rate of change. Now, you can just look at the dots and count the space, the squares, or you can look at the numbers if you want to.
I like
Counting is reliable.
Keep go ahead, get these copied down in your notes, all three, and then find the rate of change of all three.
They're copied down. I'm just
Thinking.
Wait, are we leaving at 25?
0, 2 to 0.
They're just gonna play like instruments. They should do it.
No. Kidding.
Where you been?
All right, because we're leaving early, I'm going to go ahead and talk to you about these answers. Okay, we'll call this, we'll do 1, 2, and 3. Now, as you look at number 1, what does it do on the y?
Goes backwards.
Up 3. And then what does it do on the x? Across 2. There's your rate of change. Do you see how we could just count them? 1, 2, 3 up, and then 1, 2 on the x. Okay? Or, keep your seat, Sebastian. Or, you could have found the difference. We could have done 3 minus 0 is 3. 1 minus a -1 is really 1 plus 1, which is 2. Okay, let's take a look at this one. What does it, guys, we might just have to stay a little later and have a little, or maybe when we come back, I might have to have you guys, you're wasting some time right now talking. You're talking over me, and you're not paying attention because you're thinking about where we're headed. So focus now, and if you can't, then we'll stay a little after 3:05. All right, so let's take a look from 0, 4 to 3, 0. What does it do on the y? Okay, if you go from this direction, it goes up 4. Okay? But then, what does it do if you're here? It goes back, how much? 3. So what do you think, what kind of number is going back? Negative. Now, we could have gone the other way. Like I think somebody in the back there said, you could say it goes down 4. That's a negative. but then it goes to the right, which is positive. So do you see how either way you get a negative? Okay, so that's important to notice that this ended up being a negative rate of change. Okay, now let's come down here. Okay, Mason.
So that's
Which
all
one would we usually do first?
I would always do the Y because it goes on top.
No, not like that, but I mean which dot?
It doesn't matter. You choose which one. As long as if you start with this dot when you're looking at Y, you start at this dot when you're looking at X.
So you could have started at the top. So
Mhm.
you could have got a positive.
Well, are you? Yes, but then it would have been a -4, so you would have gotten a negative for the answer. Okay, good question. All right, let's take a look at this last one. How much does it change on the Y? 0. How much does it change on the X? 3. Now, what does that simplify to? 0. Okay, so does it really change? Does it go up or down? No. Okay, so let's put some things in here. Let's say that this had no change.
So if we see a straight line that can like that, can we just say no change?
Yeah, it has 0. It has a 0 rate of change. Okay, you don't just put no change, Neil. You'd put 0. Okay, now, what type of rate of change was number 1?
Positive.
It was a positive. And what do you notice about the look of the graph?
It goes up.
It goes up. If you look at it from left to right, it's going up. Well, what was the rate of change on number 2? It was negative, and you see how if you read it from left to right, it's like it's going down. So that had a negative slope, or well, we'll call it slope later, but rate of change. So this one was increasing, whereas number 2 was decreasing. And again, read it from left to right, whereas number 3 had no change. It was a 0 rate of change. So anytime, so just quickly, what kind of rate of change would this line have? Decrease, which is negative. What would this one be? Positive.
Well, it could be decreased.
Well, you always read it from left to right. Okay? And then what about one that's just straight across horizontal?
No change.
That would be no change, so that would be a 0 rate of change. Okay? All right. We're going to head on over. I don't know. It's probably that we're going to sit with our B blocks. So that would be our normal chapel spot.